Hello everyone, welcome to lesson 4 where we're going to go through some examples on factoring polynomials. What we're going to do is look at the different types of trinomials, type 1, type 2, perfect squares, and then we're going to look at some binomials over the next 8 examples. It is really important that you get the handle on factoring because the rest of the unit will be based on you being able to factor polynomials. When you're dealing with rationals, you also have to be able to factor before you can actually simplify and do operations with rational expressions. So the very first thing we're going to do with our examples is kind of cover the different types of factoring and all the different methods. First of all, we're going to look at a couple examples of trinomials. So our first example, we're going to look at factoring x squared minus 10x plus 16. So as soon as you see three terms, you know it's a trinomial. How you identify the different types of trinomial? Well, first of all, you look at the first term. If the first term has a coefficient of 1, which this example does, we call it a type 1 trinomial. And the way you deal with a type 1 trinomial, well, is the only factors of x squared will be x times x. Then what you need to do is you need to find the factors of the last term that will add to the middle term. Now I'm going to list them all in the first couple examples, but after that then we're going to look for just the ones we need. The numbers that multiply to positive 16 could be positive 4 and positive 4, negative 4 and negative 4, positive 8 and positive 2, and negative 8, negative 2. What we need is the set of factors that multiply to 16 and add to negative 10. Well, that's going to be this group. Negative 8 times negative 2 multiplies to positive 16. Negative 8, negative 2 adds to negative 10. So when you want to write your factors, then you write your factors of your first, plus and minus your factors of the last. In this case, it's going to be x minus 8, x minus 2, and you can always check using FOIL. First, outer, inner, last. So x times x gives you x squared, x times negative 2 to give you negative 2x, negative 8 times x gives you negative 8x, negative 8 times negative 2 gives you positive 16. Simplify by collecting like terms, and notice that your factors will expand to being back to your original polynomial. Now I'm not going to check every one of these examples, but you know that you can always check your factoring by FOIL or multiplying. Factoring is basically almost the opposite of multiplication. So there's example number 1. Let's look at a second one. Example number 2. Let's look at 3x cubed minus 6x squared minus 9x. Now the first thing that you look for is you look for something that can be removed from every single term. I see x is common every term, so I can factor that out. I also know that every one of those terms can be divided by 3. So you pull out the greatest common factor when possible. Always start with that. So we're going to pull out 3x from every single term. So we're going to divide each term by 3x. So 3x cubed divided by 3x gives you x squared. Negative 6x squared divided by 3x gives us minus 2x. And negative 9x divided by 3x gives us minus 3. You always have to remove GCF first. That's the first step you always look for. You forget GCF, you will get the question wrong every single time because you haven't simplified it first. After simplifying, Notice that the coefficient on the trinomial is 1, so we're back to the type 1 trinomial. So the factors of x squared are x and x. The factors of negative 3 can be negative 3 and 1, or positive 3 and negative 1. I need the two factors that add to negative 2. That's going to be the first group. So then I can write this as 3x, and then write your factors. X minus 3, x plus 1. Done. Again, what you could do is check by multiplication. I'm not going to check this one for you. I'll leave that for you to do. You could FOIL out the x minus 3 times the x plus 1 and multiply through 3x, and you will get back to the original polynomial. So example number 1 was just a type 1. Example number 2 had us remove a GCF first, then factor a type 1. Let's go to example number 3. Example number 3 is going to be 2x squared plus 11x plus 12. Looking at this, I can't remove a GCF. There isn't anything common to all three terms. So this now is not a type 1. Because it has a coefficient on the squared term, or your highest degree term, we call this type 2 trinomial. And the way that you're going to do these is you're going to set up a factor chart. What you do with the factor chart is you look for two factors of the first. Well, 2x squared can be written as 2x and x. That's the only two factors of 2x squared. 12 can be written as 6 times 2, 4 times 3. So there are many different factors. So this little chart is kind of a guess and check strategy for you. So what you're going to do is you're going to try a set of factors. I'm going to try 4 and 3. So I'm going to write 3 and 4. Now the way that you check to see if you have the right factors is you look for cross products to add to the middle term. So notice I've just circled 3x. Now I'll circle the other cross product, plus 8x. This should add to the middle term. And I got lucky. I got it right on the first time. If it doesn't work, then you try another combination of factors of the last. Then you may need to try another combination of factors of the first. You keep going until your cross products add to the middle term. Now, a little piece of advice, you will not have a common factor in here. For example, I wouldn't be able to have 2x and 4 on the same horizontal line, because that would indicate that there's a GCF in here. So there are a few little tricks. I notice if I have two even numbers, they can't be on the same line. I can't have common factors along the same line. But you'll start to realize that as you do more and more of these type 2 trinomials. So how does this work again? Factors of the first, factors of the last, cross product adds to the middle term. And then we write our binomial factors across. So this becomes 2x plus 3, x plus 4, and then again I'll show you how to check this. Check by FOIL. First times first gives you 2x squared, outer to give you plus 8x, inner to be plus 3x, last to be plus 12. And you end up simplifying to be 2x squared plus 11x plus 12. So the factor chart works real nice. So you'll start to get quicker and quicker with the more you do. But again, remember, factors of the first, factors of the last, cross products add to middle term. Once you find the right combination, write your factors horizontally. So that's example number 3. let's get to a little bit more complicated ones. Example number 4. Let's look at this one. 5k minus 10 plus 15k squared. First thing is, when you see something written like this, you always need to write it from highest degree to lowest degree, then start to look at your question. The terms are in the wrong order. So first thing I'm going to do is write this as 15k squared plus 5k minus 10. And I notice that I can remove a 5 from all three terms, so I'm going to remove the GCF first. So 15k squared divided by 5 gives me 3k squared. 5k divided by 5 gives me positive k. 10 divided by 5 to give me minus 2. So I removed a GCF. Now I realize that I have a type 2 trinomial, again because the coefficient on the highest degree is not 1. So I set up the factor chart. The only factors of 3k squared are 3k and k. The only factors of negative 2 turn out to be negative 2 and 1. Or it could be positive 2, negative 1. So, or you might get them in the wrong, or switch their order around. You keep playing with your factor chart until the cross products add to the middle term. You may have to do this more than once. So 3k times 1 gives you 3k. Negative 2 times k gives you minus 2k. 3k minus 2k equals k. If that matches the middle term, you found the right factors. If you get something different, you got to try it again until the cross products add to the middle term. Once you find it, then you write your factors. 5 was your GCF. 3k minus 2 is one factor. K plus 1 is the next factor. So there's another example of a type 2 trinomial, this time mixed in with a GCF. Always look for GCF. After that, identify the type of trinomial you're dealing with. So far we've looked at type 1, coefficient of 1, and type 2, where we have a coefficient not 1 on the first term. Another type of trinomial that you're going to see is called a perfect square trinomial. And example 5 and 6, we'll look at two of these. Example number 5, we have 4x squared plus 20x plus 25. Now realistically, if you don't recognize this as a perfect square trinomial, you can still factor this as a type 1 or type 2 and you will still get the right answer. So sometimes students don't even bother worrying about perfect squares. If they can, great. If they can't, they don't worry about it. Again, look for GCF. I can't pull a GCF out of here, but what identifies a perfect square trinomial is that you can take the square root of the first and you can take the square root of the last. And if you can, try it to see if it is a perfect square. Sometimes it may not be, but I can take the square root of 4x squared to be 2x. I can take the square root of 25 to be 5. Keep the sign of the middle term and you write it as 2x plus 5 squared. Now the way that you check the middle term, you need to check middle term by going what we've done before when you expanded out perfect squares. The middle term, when you expand out, it's 2 times the first times the last. So 2 times 2x times 5 gives you 10x times 2, which is equal to 20x. If the middle term checks out to be what's the same in your original, then you know you've had a perfect square trinomial. So at this stage, you can get this answer. You can also do this with the factor chart as well, if you want. But if you can recognize a perfect square trinomial, it's actually a shortcut to just take the square root of the first, take the square root of the last, and write it as a binomial squared. Always remember, though, you must check the middle term. There are cases where you can take the square root of first and last, but the middle term doesn't check out, which means it's a type 1 or type 2. So you have to watch out for that. Let's look at one more of those in example 6. Example number 6 gives us 5m cubed minus 40m squared plus 80m. Again, look for the GCF first, and then we'll deal with what we're left with after. I have a 5 that's common to every single term, and I can remove an m. So first of all, I'm going to pull out 5m. 5m cubed divided by 5m leaves me with m squared. Negative 40m squared divided by 5 to give me minus 8m. And 80 divided by 5 should be plus 16. Again, looking at this, looks like a perfect square trinomial. I can take the square root of the first. I can take the square root of the last. So I will try it, and then I will test it. So I'll go 5m. Square root of m squared is m. Square root of 16 is 4. The sign of the middle term is negative. So I write it like m minus 4 squared. Check middle term. First of all, you go 2 times the first, 2 times m, times the last. I get 2m times 4 to give me negative 8m. Because this middle term matches the middle term in my trinomial that has the GCF removed, I know I factored it correctly. Again, I get what you could also do is you could check by FOIL. You can expand this all out. You could definitely check this way, but you probably notice that this is a little bit quicker. The only thing is, one more time, be very careful with perfect square trinomials. Sometimes they work, sometimes they don't. You must always check the middle term. The reason why I'm showing you perfect square trinomials is one of the later units we're going to work with quadratics, and we're going to complete the square by making perfect square trinomials. So even though you may want to just do these as type 1 and type 2, you will see later on in quadratics the importance of using perfect square trinomials. So notice in the first 6 examples we dealt with type 1s, we dealt with type 2s, and we dealt with perfect square trinomials. Learn to recognize the differences and then apply the appropriate methods of factoring for each one. The last 2 examples are very different types of polynomials. As soon as you see this polynomial, you recognize it as being something different. This example, 1 minus 64x squared, well, the first thing you notice is that this is a binomial. There's only one way to factor binomials, well, besides GCF. So if you can't remove a GCF, then what you're looking for is what we call a difference of squares. And if you can take the square root of the first, if you can take the square root of the last, and there's a subtraction sign between them, then what you can do is you can write them as identical binomial products with opposite signs. So the square root of 1 is 1. The square root of 64x squared is 8x. So I write this as 1 plus 8x, 1 minus 8x. And again, if you wanted to check, I'll show you how to check the first one. We already know from expansion and multiplying polynomials that we know if we have identical terms with opposite signs that your middle terms will cancel. If you FOIL this, first times first gives you 1, first times or outers gives you minus 8x, inners gives you plus 8x, last gives you negative 64x squared, which simplifies to 1 minus 64x squared. So just when you finished multiplying polynomials, factoring uses that process to check. So as soon as you see two terms, look for GCF. After looking for GCF, make sure you have a difference of squares. If you don't have a difference of squares, then we don't say that this is not factorable anymore. And one last example, example number 8. We have 4x to the 4th minus 4. First thing we do, look for a GCF, pull out the 4, leaving me with x to the 4th minus 1. Always look for greatest common factor first. Now x to the 4th minus 1 is a difference of squares. Take the square root of x to the 4th. That is going to be x squared take the square root of 1. That is going to be plus 1 minus 1. And you may think you're done, but then you got to look at your factors. I still have a squared factor, so I look to see if I can actually factor this further. X squared plus 1 is not a difference of squares. Yes, I can take the square root of x squared. Yes, I can take the square root of 1, but there's not a difference of squares. So the first term is no longer factorable, x squared plus 1. But x squared minus 1 is a difference of squares, so I can factor that again to being square root of x squared to be x. Square root of 1 is 1, and write this as plus n minus 1. So this could have been factored one step further, and this is one step that students always forget. They always forget to keep factoring until you can no longer factor anymore. So the x to the 4th minus 1 could be factored, the x squared minus 1 can be factored, and now I'm down to just single factors with a degree of 1. I can no longer factor them any further. So 4x to the 4th minus 4 can be factored at the bottom as 4 times x squared plus 1 times x plus 1 times x minus 1. So there's 8 examples going through the 3 different types of trinomials with some GCF practice, and 2 examples on binomials where you use difference of squares.